Hello, 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 my warriors. It's time to sprint in fluids with me, Shreyas, your captain. Hi, Pergu. Hi, Ramya. Hi, Veer. Aishwarya, nice to see all of you. Good evening, good evening, good evening. And today's session is a one-shot revision session of sprint series. And we are going to do everything in fluid mechanics with PYQ practice. All of this with your captain, your navigator. My name is Shreyas and I have been teaching kids for more than a decade. So I have taught in many offline institutes and here I am on YouTube to make sure my learnings, my teachings spread everywhere across the globe so that all those students who want to prepare for competitive examinations can ace it. And we are on JEE Enthuse, the dedicated English medium channel for your competitive exam preparation. So I will start with the basic formula revision for fluids. It would include fluid mechanics, that's statics, dynamics, then also viscosity and surface tension, all of that. Then we'll do the problems practice via PYQ. So to get started, do not forget to smash the like button and also hit the subscribe button. Blessy, I know you are under a lot of pressure and so happy that you are here. Hi Indu. Hi Shri Harshit, Veeresh, good evening Bacha. I am very good Aishwarya. I hope your sessions are going really well in your pro and I'm really hoping that you are acing it and hope to see you in the future classes as well. Hello Lucky Reddy, nice to see the new minion out here. Is gravitation the most important? I won't say the most important, but important because it's directly related to electrostatics and you can kill two birds in one stone. Hi Thala, hi Shraddha, hi Kamlesh, hi Suresh, Vanakam, Vanakam, good evening, Bachalo. Is a crash course gravitation taught? Yes, 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 because they will only teach you the most important things. There are very few important things like the gravitational force, gravitational potential energy, escape velocity, Kepler's laws, satellites. These are the 5 things that you need to know in gravitation. Your 95% of the things get covered. All right, so let's get started. And so glad that you have hit the like as well as the subscribe button. Let's start with the revision. First of all, okay, let me get my pen. When we talk about fluid statics, right? So the entire fluids chapter is divided into 2 parts. One is statics, one is dynamics. Statics is where the fluid particles are at rest. And when the fluid is at rest, there is something called as, so, oops, where did we go? Just one second. Yeah. So in fluid statics, keep this in mind that it is at rest, and the moment it is at rest, the net force is 0 and even the net torque on the fluid particles is going to be 0. And the particles which are in random motion, the fluid particles which are in random motion, they exert pressure on all the sides. So if you take the fluid particles, okay, they exert pressure of course in all the directions, something like this. That pressure is nothing but the force which they apply per unit area. Force is also the pressure into area. Also the pressure changes with height, remember that. So as the height changes, you will see the pressure also changes. So if at this point the pressure is P0 and you go down along the direction of gravity, then the pressure will become P0 plus rho GH. Rho is density, G is gravity, H is the height by which you have gone down in that medium of density rho. Okay, so all this is very, very important. Remember one more thing, that when you take a fluid, okay, you will see no matter how the shape of the container is, as long as they are connected, the fluid adjusts itself in such a way that the height across all the containers, height in all the containers will be the same. It also means one thing, if at this point the pressure is P0, at every point over here the pressure will be P0. And at the same levels, you will see the pressure is the same. So same pressure, same P at same heights, I can say, at same heights in the same liquid. This particular phenomena is important because a lot of people think that if the size of the container changes, then obviously the height changes. That's not something which is true. Yes, yeah, Arud, you can definitely cover it this summer. Hi, Avinash, welcome aboard. Hi, Kamlesh, welcome. Hi, Magical Addiction. Let's get going. Yes, we have started, Rajam Sami. Next important thing that you need to know is that, we have a term called as the Pascal's law, a law called as the Pascal's law, which says that whenever you have a closed container, a closed, or I can say enclosed fluid, then you will see whatever pressure changes occur in one part, they get distributed in the other parts till the pressure equalizes everywhere. So the pressure will always try to equalize in all the places, all the pressure changes get distributed. So pressure equalizes, and that is basically your Pascal's law. Very, very important. On that principle, you have the hydraulics, which is used in cranes, lifting machines, and so many other things. The hydraulic jack, they are all based on the Pascal's principle or Pascal's law. Okay, having said that, I have to also tell you one more important thing. See, when you have pressure, that pressure exerts a force. Force is pressure into area. But remember, there is a very important concept called as the projected area concept to find the force. Meaning, if you have a curved area, okay, imagine this is your curved area. I don't know, I'm just showing this curved area. So if this is your curved area, and let's say the pressure is acting in all sorts of directions on this curved area, okay, in all sorts of manner, okay, something like this. If you want to find the net force, all you do is find the projected area, meaning think as if light were to travel and this was an object, think how the shadow will look like. So let's say the shadow of this object looks, I don't know, maybe just like this. This is some curved object, the shadow. So this is called as the projected area. Projected is also nothing but the shadow, projection or projected area. Then whatever force the same pressure applies on this area, the same force will be applied on the curved area. So whatever force is applied on the curved area, the same force is applied on the projected area. So these two things are equivalent. Keep this in mind. Okay, this can be used for a variety of problems. Yep, I hope this is clear. Shrikar, it will be difficult, but you can definitely complete. All right. So yes, we have done the Pandu example when I taught you about pressure due to hydrostatic pressure. So with variation with different heights. So irrespective of whether you are standing under a roof or you are exposed or you are standing under a rock, the pressure only changes with depth. So you cannot escape this hydrostatic pressure. Next thing that you should remember. All right. Yes, definitely Shri Harshit, you will be able to, but also watch the crash course lecture because that's the reason why you joined the crash course, right, in the first place. So do that. Yep, definitely Benedict, he definitely should try. He should watch all the classes on JEE Enthuse and if needed, take the help from the crash course definitely. Okay. Now, the hydrostatic pressure also gives rise to one more thing called as the buoyant force. Buoyant force arises whenever any fluid is immersed, whenever any solid is immersed in any fluid, and you will see that there is an upthrust, or it is also called as the buoyant force, which the liquid exerts on the solid. If I call this as the volume submerged, if this is your volume submerged, then the buoyant force is the density of the liquid into G into the volume which is submerged or displaced. It's one and the same thing because whatever volume is submerged, that will be the same fluid which will be displaced. So they two are equal. So that is your buoyant force. A lot of people think buoyant force acts upwards. That is wrong. Buoyant force, okay, buoyant force acts opposite to the gravity, but this is the effective gravity. Meaning, imagine the gravity acting at some places down, but let's say the frame of reference is accelerated, or due to some other reason, there is another planet applying some force in some other direction, then the net gravity will change. So if the net gravity changes in direction, buoyant force will always oppose that. Keep this in mind. Okay, I hope this is clear. Fair enough, everyone? All right. Next thing that you should keep in mind is also that the buoyant force, okay, acts from something called as the center of buoyancy. Very, very important. Center of buoyancy. What is center of buoyancy? Center of buoyancy is nothing but the center of mass of the displaced fluid. So the fluid which is displaced, the center of mass of that, that's the point from which the buoyant force acts. Like when you show mg, you show it from the center of mass of that rod or the disc or the sphere. Same way, buoyant force should be always shown from the center of mass. This is specifically or more importantly used in those problems where you have a rod, it is tilted, or torque is involved in some or the other fashion. Okay, I hope this is clear. Fair enough. Next thing which you should also remember is that when you talk about flotation, that is, you know, an object is immersed and it is being balanced over there because of the buoyant force. Remember, the buoyant force will be balancing the weight. If it is balancing the weight, that's when it is floating. Else if it is sinking, then you get something called as the apparent weight. The apparent weight is the actual weight minus the buoyant force. So the actual weight minus the buoyant force, the remainder is the apparent weight. So that's why you feel yourself, you will feel that you are weighing less in water as compared to when you are outside the swimming pool because of the buoyant force. You feel lighter. Yes, definitely Ajit, it will definitely help you. After this lecture, definitely watch the nurture playlist. Everybody knows how to find playlists on YouTube, on the channel. Everybody knows how to explore the channel tabs. It's very simple, right? Go to home page, about me, playlist, so many things, videos are there. Go to playlist. In that you will see 11th, 12th, KVPY, JEE preparation, so many things. So go to 11th standard. Then you will see physics chapters are arranged. Watch the fluids playlist. Is that okay? Very good. The buoyant force is not upwards. It's always opposite to the net gravity. Vankadari, Rajeshwari. Okay. If gravity acts here, it will be opposite to that. If gravity acts down, it will be opposite to that. Okay. No problem, Rijita, join in. You're not very late, but you can definitely catch up. Hi, Ankit, nice to see you back. Next thing, in fluid dynamics, the concepts that you will be using is equation of continuity. For equation of continuity, you need something called as the rate of flow, which is also called as volume flux, and volume flux is area into velocity. And for an incompressible fluid, you can say the rate of fluid which is going in is the rate of fluid which is going out. That means A1 V1 will be A2 V2. If the cross section changes, the speed also changes. When it becomes narrow, when A becomes less, the speed increases. Similarly, if you have two cross sections, you can also apply Bernoulli's principle, and Bernoulli's principle is simply put the pressure plus half rho V square plus rho GH is nothing but constant, and this comes purely from energy conservation, and there are no viscous drag forces present in that particular flow. So pressure plus half rho V square plus rho GH is constant. That means P1 plus half rho V1 square plus rho GH1 is equal to pressure at the other point plus rho GH2 plus half rho V2 square at the other point. So this is very important for solving questions. Torricelli's law, Venturi meter, pitot tube, all these questions, the lift produced by an airplane wing, all these questions are based on Bernoulli's principle. Important thing to note is whenever the speed increases, the pressure decreases, because the sum of pressure and half rho V square should be constant. So if this guy goes up, this guy will go down. So low pressure is created where the speed is higher. Keep this in mind. Okay, Ajit, you read my mind. I'm going to do a session probably by tomorrow or day after, where I'm going to give you short topics for JEE 2022. But 2023, you are too early for that. You have 1 year. Guys, if you are 11th standard, how many of you are 11th standard? Let me know in the chat box. Dinesh, if you have not completed this chapter before, then it will be slightly difficult. You will get some idea of the chapter, but after watching this, watch my nurture classes. I've conducted at least 5 or 6 classes on fluids alone. Watch all those classes. It will take 1 to 2 days. It's okay, but you have time. You are in 11th standard. Even if you are in 12th, that's okay. You still have time. You can make the best use of that material which is available for you guys. I have taken so much of pain to create all these content, guys. So make use of that content, and don't waste your time just scrambling for content everywhere else. It's there. So all my students, all my dear warriors who are in 11th standard, do not focus on important topics. That is the worst mistake. Some YouTubers also do that, and especially for the 11th standard kids, do these topics only if you are in 11th standard. We do not do that on JEE Enthuse because you have 1 year time. Make use of that time. Why should you study only selective topics? You have the potential to crack about 200 plus, and for that you need to solve all the questions from all the chapters. Don't remove any chapter out of your books, or don't skip any content. Okay, let's do the next thing, and that is your Torricelli's law. So when we have to talk about Torricelli's law, basically we are talking about a fluid which is in a container, and the container contains that fluid till a height of, let's say, h, as compared to where the orifice is. This is also called as the orifice or the small opening, and you will see the velocity of that efflux. The velocity of the efflux is root of 2gh. Okay, root of 2gh, very important. Similarly, imagine if the total height from the base, if it is h, that's from the base, then the range, remember, it will fall somewhere. So this is the range. So the range r is given by root of 4. You will have basically h, and you will also have h minus h. This is the formula. Keep this in mind. Okay, very, very important. Is NCERT enough for mains, Swapna? Definitely not. If somebody has told you, they have definitely fooled you. Okay, please do not do only NCERT. You have to go beyond NCERT. You have to do Tattva exercise 1, the PYQs, you have to do the assignments, mock test, so many things, the class notes, you have to solve variety of problems from the books I have recommended. Then you have a scope of getting good marks in mains. Else, you might get 80 percentile, 70 percentile, but that's of no use. Hai na? Thank you, Ajit, so much. Love you, bacha. All the bacha log from Andhra. Next concept that we need to know is the layers which slide amongst each other with respect to each other. They experience something called as a viscous force, and Newton gave the law of viscosity. So what was the law of viscosity? Whenever one layer slides with respect to other layer, you will see that each layer pulls the other layer, and the force of drag which was given by Newton was eta a dv by dx. This is your Newton's law. Newton is there everywhere, right? Newton's law of viscosity. What is eta? It is called as a viscous coefficient or viscosity. Viscosity or viscous coefficient. This dv by dx. What is dv by dx? Rate of change of velocity with respect to that distance of separation between them. That is your velocity gradient. That is your velocity gradient. Correct, my warriors? Yep, definitely. Concept wise, see, you cannot argue like that. Concept wise, is it more? But difficulty wise, yes. And variation wise, yes. You will need more than NCERT. Okay, great. You are in Pathfinder series follower, Dinesh, and I completed 12th standard with my videos. One last chapter pending, semiconductors. Very good, Dinesh. That's it. Hats off to your spirits. One chapter you will complete within few days. Definitely. Next thing that you need to know is that whenever you have a sphere and it is moving with speed v, then it experiences again a drag force. This is given by Stokes, which was 6 pi eta rv. This is your Stokes law, correct? This is your Stokes principle or Stokes law. Based on the, what is R? R is the radius. What is V? V is the velocity. So any sphere you throw, it experiences a drag force opposite to the direction in which you are projecting it. Remember, this formula is only applicable for spherical bodies. For triangles, squares, other shapes, you do not have it in JEE syllabus. Great. Theory wise, yes, you will need H.C. Verma. So the only book which you need for cracking JEE Mains and JEE Advanced theory is, apart from NCERT and the Tattva module which Vedantu gives you, you need only H.C. Verma, nothing more. You can get all India rank 1 using these 3 books. That's all. That's all, bacha. That's all. I'm telling you, no, nothing else. My students who have got all India rank 10, 12, 2, all these students, right? They have just studied coaching material, the H.C. Verma, NCERT, nothing else. Okay, a lot of people tell you do this book, do that book. Yeah, problem solving ke liye you need other books. Theory, nothing else is needed. Yeah. Okay. Next thing, terminal velocity. When a drop falls from the sky, eventually the speed becomes constant. That is called as the terminal velocity. The formula is 2/9. Correct? And you have R square, you have eta, you have G and sigma minus rho. What is eta? Viscosity of the medium in which it is falling. R is the radius of the drop. G is gravity. Sigma is the density of that object or that solid, whatever it is, solid or basically that drop. And rho is the density of the outside medium. This is how it is. Okay, all these are important formulas. Next thing, let's move on to surface tension and let's get quickly to questions. I know you guys are all excited for solving questions. I'm coming there, but yeah, we need to brush up theory, right? And I am hoping that you guys love the brush ups before I do in these sprint sessions, so that you get a hang and complete picture of the chapter before you start, right? And if you love this, please give a thumbs up and smash the like button down there. Okay, next, quick revision of fluid mechanics for the surface tension part. Remember, surface tension arises due to the property of the fluid to contract on its surface. So surface tension is nothing but the contraction force which acts per unit length on the surface. So basically, due to this property, it tries to always minimize the surface area. Very good. Ankit, if you can bunk, you should bunk, Ankit. Okay. And if you have any fluid surface, let's say like this, okay, this is your fluid surface, and let's say I draw a line over here, and this is having length L, then the force which acts across that line, that F will be given by SL. S is the surface tension, L is the length on the surface for which you are calculating that force. Also, any surface area which is exposed, in this case it is this one, this is that area A. That area which is exposed has surface potential energy, because more the surface, more unstable it is and more potential energy is there. It will minimize the surface, then it will have less energy, it will become more stable. Hence, what will happen is that the potential energy is given by USA. Remember, United States of America, potential energy is S into A. S is surface tension, A is the area exposed. Okay, definitely Swapna, I will probably reply. Can you just do one thing, comment on one of my pictures or something, so that I can know which one is your profile, okay? Or else I might again miss that message for some reason. Okay. So you are a NEET aspirant, Dinesh, and you have completed the Pathfinder like you said before, and you do not know any chapter in 11th. I would suggest you to watch my Zero to Hero first. Once you watch Zero to Hero, you'll understand which are your weak points. Based on that, start watching my nurture classes. Watch those videos where you find it difficult to understand the concept, so that you get a detailed explanation. That way you will be able to complete the syllabus, and then obviously meanwhile you should continue your practice with PYQs, Tattva, assignments, whatever material you have. Okay, next thing that you need to remember in this particular concept is that whenever you talk about curved surfaces which are separating two different kinds of medium, there is a pressure difference which arises, and the pressure always is more on the concave side than on the convex side. Like the drops or the bubbles, always you will see the pressure inside is more, pressure outside is less. So if it is one surface, so pressure on the concave is always more than the pressure on the convex. This is your concept of excess pressure. So for one surface, and then you have for two surfaces. So what's the formula for pressure difference? So for one surface, the excess pressure is 2S by R, and for two surfaces, the pressure difference is 4S by R. When I'm talking about two surfaces, the examples would be that of a bubble in air. A bubble in air. You can see there is air and liquid interface inside the bubble, and there is also liquid air interface outside the bubble. So there is one surface inside, one surface outside. When I talk about one surface, example wise, I can say a drop of water in air, or I can also see or talk about bubble in a liquid, because then there is only one surface which is there inside. I hope this is clear. Is there any difference between air bubble and soap bubble? I'm not sure. What do you mean by air bubble? A bubble in air, I can call it as an air bubble. That bubble can be made up of different things. It could be made of soap or some other materials too. So usually when I talk about bubbles, I need to be sure whether it is in air or whether it is in a liquid. Air bubbles can also mean the bubble which is made of air inside and it is inside water. That is also the most likely interpretation of that. Okay, thank you, Unique Gamer. Hi, MYK. Hi, Sandhya Rani Nayak. Okay, is that clear? Saifu, usually when we talk about air bubbles, we mean that it is filled with air and it is inside water. But when you talk about soap bubble, we usually mean that it's a liquid surface is made of soap and it is inside of air. Okay. Yep. Madhusudan, I would suggest you to first clear your mains portions, because mains plus boards is going to be very hectic month, the next 1.5 months, and I am doing something for you guys for advanced on this channel. Okay, don't worry about it. Let's go ahead. Okay, next, the last things that we need to know in surface tension regards to this chapter is your capillary rise, capillary fall formulas. Theta is also called as your angle of contact, and it's always between the solid and the liquid pair, and it can be acute, it can be obtuse. If it is basically obtuse like the one which is shown over here, then you can say that the cohesion is more than the adhesion. But if it is acute, then you can say that the adhesion forces between the liquid and the solid is more. That's how we can differentiate. And you will see when you take a capillary, the liquid will rise up into the walls of that capillary, and the height by which it rises, so capillary rise or fall, can be given by 2s cos theta by rho g r. What is r? R is the radius of the capillary, rho is density, g is gravity, s is surface tension, cos theta, theta is your angle of contact. You can see if angle of contact is acute like the one here, it will rise. If theta is obtuse, then cos theta will be negative, that's the second quadrant, that means it will fall like in the case of mercury of inside glass. And if theta is 90 degree, cos 90 will be 0, that's the case of water in a silver container, that's when it will neither rise nor fall. Okay, these are the things which you should remember. Okay, cool. Let's get moving to some questions coming up on your screen, and we have to challenge our seniors. That's the reason why we are conducting all these sessions out here. All these sessions are with fresh questions, fresh concepts in a very different, redesigned manner, so that you have more content year on year. Obviously, you have your last year's content and you have this year additional content which we are giving you on this channel, so that you guys ace the papers this time, because you just have 2 attempts, not like the last time where you had 4 attempts. These are our toppers who made us proud. This time the ball is in your court, where you have to make the mark and make sure that next year when I'll be teaching kids, your photos, your names should be here. Even if your photos are not there, I'm okay. If you are in one among these numbers, I'll be very happy. And we at Vedantu celebrate and appreciate and respect each and every rank. It's not always about top 10 or top 5 or top 3. It's about every rank, because each rank is a story. Let's start with the question number 1 coming up on your screen. Okay. JEE paper 1, paper 2A, paper 2B, they are different, bacha, in the sense paper 1 is for BE Tech, that means engineering courses. Paper 2 is for architecture and B plan. Okay, that's a separate branch. I won't say engineering, but it's architecture. Like you have medical, science, engineering, that's architecture. So paper 2 is for architecture. If you are going for only engineering, you just need to give paper 1. But if you are going for architecture, then you need to go for paper 2. Okay, is that okay, Yuva? All right. Yes, I know, Saifu, I do know. All the sirs in obviously Vedantu. Obviously, I'm leading the physics department. I would know everyone. Okay, let's get going with the first question. 3 vessels are shown. They have exactly the same base area. Equal volumes of liquid are poured in the 3 vessela. Ooh, vessela. This sounds like very South Indian. You know, once what happened, you know, I had come to Bangalore long time back, and I was in the bus. I had to travel somewhere, and the conductor over there was asking me tickets, but I was not able to understand what he was saying. He was basically asking me the pass or tickets. So I was telling him that, listen, I have pass and it's in my bag, and I am finding it difficult to take it out, and I'm very lazy to take out the pass from my bag. So he couldn't understand. So my friend is like, you know what you should do? Just say the word pasa. Like, pasa. Then he was like, yeah, you have it. And he just understood everything. You just add A after everything, it suddenly becomes more comprehensible. Yeah, so you don't use the word pass. You should say pasa. Then he will be like, yeah, now I know what you mean. Yeah, so this is a vessela. Okay, so the vessela, the force on the base will be how much? Let's try to figure this out. Okay, come on, my warriors, figure this out. Volume is same. Volume is same. Volume is same. Keep this in mind. If volume is same, mass is same. Mass will be same. That means same quantity, but the shape is different. Hence, the heights will be different. Obviously, volume is same does not mean height will be same. Look at the shape, right? So, if in this container, this much fluid is there, then in this, because it becomes broad, obviously it won't be till that same height, it will have lesser height, correct? The height will be less. And where it becomes narrower, obviously you will have to have larger height. And the question is force on the base. Guys, the force on the base will be the pressure at the base into the area. And the pressure on the base will be rho GH into area. H is different. Here H is less, more, highest. So pressure is less, more, highest. Force is less, more, highest. So C will have the highest, and it will be the least in vessel A. Okay, yes, maximum in vessel C. Minimum is not there, but if minimum was there, it will be in A only. Got it? Yes, so it is maximum in C. So A is less than B is less than C. Just because of their heights, my warriors. Just look at the heights. The heights keep changing because the volume is the same. Moving on to the next one. coming up on your screen. No, many of you are wrong. Can we write both paper 1 and paper 2 in the same year, both same time? No, you can't. Okay. Yes, Ramya, I do have the question levels changes from one to other. The figure shows a semi-cylindrical surface of radius r, length L. This is the cylinder, this is the liquid. The cylinder is like this, inside and outside the plane of the board or the screen. If the pressure of the liquid is P, you can see that, then the net force by the liquid on the surface is how much? Okay, the logic goes like this. The pressure in the liquid is P. The pressure will be exerting forces somewhat like this everywhere on the curved surface, correct? In order to find the net force, I have one option to integrate the forces taking the components, and then after integration I can find the net force. The second option is using the concept of projected area, which I just taught you. This is a cylinder. Visualize this. Okay, just try to visualize. This is a cylinder. Okay, just visualize. And yeah, maybe like this. I can show it. This is your cylinder. And you want to find the net force. You can see that the net force by symmetry, because there are forces here, there are forces here, forces here, forces here, forces here, forces here. All these forces will give a resultant in this direction. Do you guys agree? There will be a resultant force in the horizontal direction, because each force will cancel their y components, only their x components will keep on adding itself. Now, in order to find out the projected area, imagine the rays of light coming from here. How will the shadow or the projected area look like if the rays of light come from here? Okay, if the rays of light come from here, how will the shadow of this cylinder look like? Come on, this is very easy. Put it up in the chat box. Come on, this is very simple. How will the projected area of a cylinder, look at this, the semi-cylinder is kept over here, light rays come from here. How will the shadow of it look like on the other side? Think. There is no option, Sakir Marfetya, there is no option. This is a subjective kind of thing. The shadow will be just a rectangle, right? And what will be the size of the rectangle? The height will be 2r and the base will be length L. Now, instead of finding the force on the curved area, all you need to do is find the force on the flat or the projected area, because this one is basically your projected area and both will experience the same force. So hence the force will be pressure into area of projection. So pressure is P, area is 2R into L. That's the answer, 2RLP. That's it, done, done. Very good, Siva, excellent. Moving on to the next one, 2PRL, sorry. Okay, thank you, Ramya. A jar is filled with two non-mixing liquids. Densities are ρ1, ρ2. Another solid, a ball made of material ρ3, is in the jar and it stabilizes somewhere over here. It comes to equilibrium as shown. Which of the following is true relationship between the densities ρ1, ρ2 and ρ3? Think. Oh, Venkata, is it? Acha, I'll do it someday, bacha. Okay? I need to find people also, no? It's not so easy. And that too, I need to find good people. So it takes time, but definitely if I find someone, I'll definitely do it. Because whenever I will do videos, I will always think about the quality. I won't just do any video for the sake of doing it. I'll wait and find the right person, or I'll wait for the right time, or I'll wait for the right information and then only do it, because I care more about the quality than just doing it for the heck of it. Okay, so let's try and do this question. This solid is sinking in liquid 1. The ball sinks in liquid 1. It means ρ3 is more than ρ1. ρ3 is more than ρ1. But if you notice, the same ball is floating, it floats on liquid 2. Hence, the density of that solid definitely must be less than the density of that liquid, which is rho 2. So combine both of them. What is the answer? Check it out. Obviously option B, right? Rho 1 more than rho 3 more than rho 2. Rho 1, okay. I think this is exactly wrong, guys. This should have been the opposite. This should have been D, not B. Okay, I'll get it corrected. This is not supposed to be B. Ignore that. It is supposed to be D. Okay, so D option is correct. I'll just mark it right over here. All right. Okay, it is exactly opposite. It's not B. It's D. Okay, fair enough, guys. Understood? Clear? These kind of questions were asked in JEE. This was JEE 2007 question. Now, this is a very good question, advanced question. Are you ready for this? Okay, so this is a JEE Advanced type of question, and let's see how to solve this question. There is a circular tube and there are two liquids. This has density D1, that has density D2. Both of them are in equal quarters. This is one quarter, this is another quarter. Alpha is the angle made, and the question is, what is the ratio D1 by D2? Okay, now here is the logic for this. Whenever, see guys, you have a tube, okay, whenever you have a tube and you have two different liquids, maybe there is liquid 1 over here, okay, there is liquid 1 over here, and maybe there is some another liquid over here, okay, there is another liquid over here. You have always, whenever you have to find the relationship between density, heights, whatever, you always equalize the pressure at some 2 points, and in this situation, notice that this point and this point, they are in the same liquid, so pressure at this point 1 and pressure at this point 2, they will be equal. So always look for 2 points where you can equate the pressure. Okay, Akash, I wish I could change it, bacha, but you know, this is like a pure English channel, so we have a English channel, Hindi and English mix, Vedantu JEE channel, but इस channel पर तो पूरा अंग्रेजी होगा, ठीक है? I hope you are okay with it. I'm pretty sure you will get used to it eventually, because when you go to colleges, when you go for higher studies, they will teach you in pure English. They will not teach you in English or Hindi also, you know? Okay, let's get going. Now, good evening, Kalyani. Nice to see you. And I guess you are a silent spectator all this while. So, moving ahead, I will say that at this point, whatever pressure of the liquid comes from this side, I'll repeat, at this point, the bottommost point, whatever pressure of the liquid comes from this side will be the pressure of the liquids coming from this side. That's the reason why it's an equilibrium, right? Pressure from this side and this side should be equal. Hence, it is not rotating, turning, it's just stationary over there. Okay, great. Now, there are a lot of things that you will learn from this question. Okay, it's going to be very interesting because there is a lot of geometry plus the concept of hydrostatics. Observe this carefully because many students found this question very difficult in the JEE Advanced examination. So let's start with this. First of all, remember, pressure changes only with height. So this shape technically does not matter. What matters is the height. So think about this part. So the upper surface is over here, the lowermost point is over here. So all I need is this height to calculate how much extra pressure is there because of this part of the liquid. The liquid in this part will create pressure because of this height difference. Let's say I label it as H1. I label it as H1. Okay, how do I find H1? That's another story. I'll come to that. But before that, if this is alpha, obviously this will be also alpha because this is 90 minus alpha. Alpha, 90 minus alpha, alpha, because this is 90 degrees, right? Okay, fair enough. Now observe this. Now observe this. H1 can be calculated this way. This whole thing is R, right? Because this is the radius of the circle. Is the radius of the circle. So let's put it somewhere. Maybe here. This whole thing, okay, this whole thing is, let's say, r. Only this much will be, because even this is radius, this much from this point to this point, shouldn't that much be r sine alpha because it is opposite to alpha? Observe that. So I'll mark it right over there. Only this much, okay, only that much will be r sine alpha. I hope everybody agrees to this point. Now, if this is r sine alpha, this hole is radius, this one, h1, what will h1 be equal to? Think about it carefully. h1 will be this minus this minus this will be this. So it will be r minus r sine alpha. That means it will be r into 1 minus sine alpha. Everybody clear till this point? Nice to see you back, Abhishek. Siva, I was not so great at English, trust me, but over time I have improved. Okay. Glad to know that, Akash Kumar, Sagar. Okay. Now, the same things we should do on the other side also. Let's start doing it. Okay. Observe now carefully. First thing, let's try to find how much is this height. Let's say I call it h naught. Okay. Let's say I call it h naught. How do I find this height h naught? I can find h naught by finding this height minus this height. This height, that is r. This much height, think. Because again, this whole thing is radius r. This whole thing is radius r. In this triangle, if this is r, this is alpha, what is this height? Look at the triangle, guys. This small triangle, this is hypotenuse, this is alpha, this is the adjacent side. Shouldn't it be r cos of alpha? So can I say that only this much, whatever you see over here, this much, this should be r cos of alpha. Okay, this is the one that I'm talking. Hence, what will be h naught? H naught will be complete r minus this part, which is r cos alpha, which will be r into 1 minus cos alpha. Fair enough? Very good. Next, I need every heights, only then I can start with the problem. So a lot of geometry involved, like I told you. Without this geometry, I will not be able to write even one equation. I will try to find how much is this height. I need that because I found this height. I need to also find how much height of liquid is there for the density 2. So how do I do for that thing? Draw a line over here, and I can see that if this is alpha, obviously even this is alpha. Obviously even this over here, because this is radius r. So obviously this one over here will be r sine alpha. You can see that only this much will be r sine alpha. Also to note that what is this? This yellow line is r cos alpha. Yellow line is r cos alpha. So from here to here, what will it be? This plus this dark yellow plus this red, which will be r sine alpha plus r cos alpha, which is nothing but r into sine alpha plus cos alpha. I'm just going to call that as h2. Okay, so that is h2. So I'll just call it as h2. I need all these things. Well, William, this is for 11th and 12th standard. Yes, I will be teaching sadhana. Don't worry. All right. Now, here comes the tricky part. The pressure of the liquid from this side, so I'll just write it. The pressure of the liquid from this side should be the pressure of the liquids. Here it is only one liquid. Here you have two liquids from this side. The pressure of the liquid from this side will be due to only this D1 liquid of height h1, because remember, only heights matter. This lateral displacement does not matter at all. Horizontal does not matter at all. So what's the height of that liquid? That is rho is rho is a density, so it's given to be D1. So it will be D1 rho GH, G is G, H will be just H1. Think about it. It will be just H1. Fair enough? It will be just H1. And from the other side, this liquid plus this liquid's pressure. This liquid has a height of H0, which is density D1. So D1 G H0. That's another thing. Okay, I'll just put it over here so that in the same color so that you can see it very clearly. And the last thing that will come is this liquid. This liquid is having a height of H2. This liquid is having a height of H2 and density D2. So the pressure contribution for that liquid will be D2 G H2. That's it. This is the pressure equation. Yes, this sum is crazy. This is no, Siva, look at this. Advanced. This is an advanced level question. Hai? Yeah. So this is how you need to arrive at this equation. You cannot write this equation unless and until you have found this out. Maybe you can write this, but then you will realize, oh, wait a minute, I need to know H1, oh, I need to know H0, oh, I need to know H2. And then you will do all this geometrical business and then again come back over here. Okay, let's start writing these things down and see what do we get. Anyways, G gets cancelled. D1 will be, D1 is D1, H1 is nothing but R into 1 minus sine alpha, of course, and D1 is D1, H0 is R into 1 minus cos alpha, and D2 is D2, G goes off, H2 is R into sine of alpha plus the cos of alpha. You can see R goes from everywhere. So you are left with D1 minus D1 sine alpha is equal to R has gone. So D1 minus D1 cos alpha plus here you will get D2 sine alpha plus cos of alpha. I will not expand it. From here you can see D1 and D1 cancels. Take this guy over there. So you will get D1 cos alpha minus sine alpha will be equal to D2. You will have sine of alpha plus cos of alpha. Now I think I need the ratio D1 by D2. So shift D2 here, throw this guy downstairs. So D1 by D2 will be equal to sine of alpha plus cos of alpha upon cos of alpha minus sine of alpha. But I can see all the answers are in tan and I don't see any sine cos matching over here. So I should be quickly able to think about it mathematically, that if I divide the numerator and denominator by cos alpha, probably I'll convert it into tan. So look at this, sine by cos will be tan alpha, cos by cos will be 1, cos by cos is 1, sine by cos is tan. So I think I have arrived at the answer. And is it matching somewhere? 1 plus tan, 1 minus tan. It should be option A, guys. Is this one of the tough sum, or all sums be like this? All sums won't be like this, but this is one of the tough sums. Yes, Abhishek. Hi, Satvika, ready. In NEET student view, this is very difficult, obviously. Yeah. Jia Singh, can you do bacha one thing? Can you just rewind? Even in a live class, the advantage of YouTube is when you learn from here, rewind in a live class and you can catch up again. Watch it again and again. Trust me, this sum is more of you doing it on your own. You have to draw a rough diagram, pause the video, watch it, try it, and then convince yourself that yes, this is R minus R cos alpha. Oh, this is this. Only then you will get it. The major confusion over here happens because when you draw this tube thick, if you draw this tube thick, then you get confused. Should I take this point or that point? So draw the tube very thin so that you don't get confused between the 2 points of the tube. That's where most of the people got confused in 2016. Okay, Jia? So just try this out. All we have done is I'll give you a brief about the problem. This liquid is at rest, the entire thing. This is one quarter, this is another quarter. So at this point, the pressure from here and from here should be same. So for the pressure from here, I need this height, which is the one in green. That's what I've written over here, rho GH. And for the pressure from this side, it should be the pressure of this liquid, which will be because of this height, which I have written in yellow, and plus the pressure of this liquid of density D2, which I have written down in blue. That's it. That's all I have done. Rest is geometry. Okay, great. All right. I hope this is fine. This is a very good question. Watch this video again and again if you want. It's okay. I hope, Jia, now you got a gist of it. I hope you will be able to watch it again and you will try to convince yourself. Trust me, once you get it on your own, no, that joy is tremendous. Nobody can, take over that. Nobody can replace it. And next question is a hollow spherical shell. Outer radius r just floats submerged under water surface. The inner surface of the shell is r, small r. Specific gravity of the material is 27/8 with respect to water. What's the value of the inner radius? Let's try this question, guys. Okay, ready to try this question? It is going to be very, very interesting. Okay, let's draw things first. JEE 2020 question. This is my liquid. Okay, the liquid has a density rho. The solid just floats. You can see that is just submerged. Just submerged means it is like this. This is the meaning of just submerged. And there are two radius. One is the outer radius r. The second one is the inner radius r. Remember, it's a thick shell, meaning, oops, I think I'll just use this one. Yeah, meaning that this part is made of that material. Some material, let's say I call it sigma, density is sigma. Okay. Now, what are the forces acting on this shell which is floating? Number one, obviously, there will be buoyant force. Buoyant force will be acting upwards, obviously. And number two, the weight of this shell will be acting downwards. And since it is just floating, the buoyant force must be just equal to the weight. Correct? And what's the formula for buoyant force? Is density of the liquid into volume which is submerged into G. What is weight? Weight is mass into gravity, but I don't think I've been given masses over here. So might as well write it as density, okay? Density of that solid into volume of that solid into G. G, bye-bye. Okay, G has gone away. Next, what is the density of the liquid? Density of the liquid is rho. I've just assumed it to be rho. What is the volume submerged? How much volume is submerged? This is very interesting. Many people get confused here. They think, sir, it's a hollow shell, so inside also, should you count it or not count it? Guys, what is there inside really doesn't matter, because only the outer surface matters. So understand that when the sphere is immersed, no matter what you fill inside, the volume submerged will still be remain the same. So it will only the outer radius will matter. So I'll just have to put this as 4/3 pi capital R cube. Did you understand why I put capital R cube? Abhishek, most likely I think it is waves as far as I can remember. Yep. Next thing. What is the next thing? Density of the solid, I just assumed it to be sigma, but remember this sigma, be careful, this sigma, because the specific gravity is mentioned, it is 27/8 times of water, meaning it is 27/8 into rho. Make sense? So how about putting the density of the solid as 27/8 into rho? Okay, the next thing, what is the volume of the solid? Many people get confused and they write 4/3 pi r cube. That's not the correct answer. The solid is only there in this part, inner part is hollow. So technically speaking, it should be 4/3 pi r cube minus r cube. Reason? The inner part has to be ignored. It's hollow, only the solid chunk should be taken. Now it becomes simple. You can see rho gets cancelled, pi gets cancelled, 4, 3 gets cancelled. So you will just have r cube over here, you will have 27/8 over here, and here you will have obviously r cube minus r cube. So 8 goes over here, so 8 r cube is equal to 27 r cube minus 27 small r cube. So 27 small r cube, 27 minus 8 is 19 r cube. So just shift it, juggle it around, and you will get the answer, I suppose. So what is asked? What is the value of small r? Okay, so r cube will be 19/27 into capital R cube. So r will be cube root of 19, cube root of 27 is 3, and r's cube root is r, of course. So cube root of 9 by 3 comes roughly close to one of these. Just check it out. If it comes out to be 8 by 9, if it comes out to be 8 by 9, roughly it comes out to be 8 by 9 times of r. Is that okay, bachcha log? And this is fairly easy. Only the tricky part is this one thing. You have to convert the density. Number 2, while writing the volume of the solid, you need to be very careful. Only the solid chunk you should take. And while writing the buoyant force, the entire volume has to be considered. That's how you solve this. Okay. Now this is an easy one on hydrodynamics. Let's see how many of you can do this. This was asked in JEE 2020. Come on, let's see. I will give you 1 minute time and see how many of you can do this. It's very straightforward. A fluid is flowing through a pipe, varying cross section, speed V. At that point the pressure is P. At another point where the pressure is P by 2, the speed is capital V and density is rho. What is capital V equal to? No, Jia, NCERT is not sufficient. NCERT is must. It's necessary but not sufficient. You understand, right? Necessary but not sufficient. Okay. So necessary and sufficient. So this is NCERT is needed, but to get a rank, to get a college, to get something, some NIT, some branch, a decent one, respectable one at least, then you need to practice PYQ, assignments, previous year questions with mock tests, and also lots of variety of problems along with theory from books like H.C. Verma, especially for physics. Oh, I forgot to start the timer. Let's start the timer now. Come on, let's see how many of you can do this. It's not that difficult. Try it out. Use Bernoulli's principle. Trust me, you will land with the answer. Flash, it depends on how you take it. If you have faith, it is good. If you don't have faith, then it is not good. Because the most important thing in any coaching, even in offline, no matter which offline you go, no matter which online you go, you should have faith that yes, I can crack it. You should get that confidence, number 1. Number 2, you save on time, traveling. Number 3, you can watch recorded classes if you miss it. So no chance of missing a class that way. And all the other things that I would say, additional things, is you get all the important data points, report cards, which are based on your time and your in-class performance. And the most important thing at Vedantu, you get basically 2 teacher model where 2 teachers are teaching you. One is actually teaching, the second one is solving all your doubts. All this is not possible in offline. That's how it is. So all the students from Vedantu have cracked studying, sitting at home. So why not you? Definitely you can crack it. Ankit, like I said before also, your parents are from a different generation. They will not understand the importance of JEE. So you should focus on JEE. You should convince them. It's not their fault. They feel that JEE is not so important. But remember, JEE is the one which will give you ranks, which will give you college, which will give you branch. Boards, not even eligibility. So, you know what. Now, okay, some of you are saying B. Here is the thing, guys. The fluid is flowing in a horizontal pipe. So let's say this is a horizontal pipe and pressure becomes P by 2. Okay. So I can use Bernoulli's equation, which is pressure plus half rho V square plus rho GH is a constant. Now since the word horizontal is used, even H is a constant. So hence initial pressure plus half rho velocity square will be final pressure, which is P by 2 plus half rho new velocity is capital V. Now P by 2, if I take it on the other side, P minus P by 2 is again P by 2 plus half rho V square will be only half rho capital V square. Half goes, so I'll just be left with P plus rho V square will be rho capital V square. Bring that rho over here, so P by rho plus V square is equal to capital V square. So we will be root of this. So I think option B should be correct. P by rho plus V square. Correcto. Yes. Excellent. Okay, very good. Yeah, you have Vedantu subscription, then you should make full use of it, bacha. Full use of it. Is it correct to repeat again a year for JEE preparation after 12th? It's correct. There is nothing wrong in it. but you should never let yourself come to that point. You should prevent that. I mean, you should always avoid a drop, but taking a drop is not bad. You can take a drop and there is nothing wrong in it. You do not lose anything in it apart from 1 year. Okay, that's it. Apart from that, there is no side effects. Okay, chalo, let's get moving. The next one coming up on your screen. Here it is. No, Pranish, when you register does not matter. So a lot of people say if you register early, then you get a seat or city and things of your preference. Nothing like that. It is completely random. So don't go by such things. Okay. A cylindrical vessel of height 500 millimeter has an orifice. This is brilliant question. You will understand why. Small hole at its bottom. The orifice is initially closed and the water is filled in it up to a height of h. Okay, let's draw everything. This is not so easy. Okay. If I read everything, you will get confused. Okay, so let me draw over here. Okay, so this is your container, like you can see. Okay, and there is a small hole at the bottom. And the cylindrical vessel has a height of 500 millimeter. So 500 millimeter. So that is the height of that cylinder. And the orifice is initially closed, so it's completely closed. Okay, filled up to height h. All right, so the liquid in it is filled till height h. Okay, so this is basically height capital H. I don't know how much it is. Now obviously if it is the jar or the container is just closed, initial pressure will be P0 over the water surface, the air which is trapped above the water surface and below the top lid of that container, that cap which is there. So now what you do, now the top is completely sealed. You have sealed it, the inside air is trapped. Remember, this air is now trapped. It cannot go anywhere. Now you open this, what will happen? The liquid level will fall down. So let's see what happens next. So again, let me draw the container. You open it up. The moment you open it, the liquid level will fall, but do not forget there is trapped air inside. That air will expand. What happens when air expands? If the level falls, the air expands, the pressure decreases. If pressure decreases, it will create a suction and it will prevent the liquid level from going down further. If it creates a suction like thing, because pressure has reduced now, so it will prevent the liquid level to fall further and the water level will reach a new equilibrium. So you will see the water level will definitely fall. Okay, and the fall, the new height becomes 200 millimeters. This is the new height. How much is it? It's 200 millimeters. This is when the water has just come out. Very interesting. So the question is, figure out how much is the fall. That's the question. Everything else is given: atmospheric pressure, density, gravity, everything. Neglect any surface tension. Yeah, Ramya, maybe someday. Definitely. No problem, Siva. Board exam postponed. Who says so, Surya? Is it Tamil Nadu board or is it Karnataka board? You should let me know. Okay. So here is the thing. When the trapped air expands, the pressure will change. So first of all, let me assume the new pressure to be P. Okay. When it reaches a new equilibrium, why will the water stop to ooze out? Listen in carefully. The vessel becomes steady with the height of water column being 200 millimeters. The reason why the water level falls and does not change after that is because whatever pressure is there from this side, which is pushing the liquid out, will be balanced by the pressure of the air from outside. Hence, the water is not able to go out nor come in. Hence, I can say at equilibrium, the pressure from inside is equal to the pressure from outside. And the pressure from inside will be P plus rho GH. It will be P plus rho GH. This will be equal to the pressure from outside, which is P0. Now this rho is 10 to the power 3, G is 10, height is 200 millimeters, which is 0.2 meters. is equal to P naught. P naught is 10 to the power 5. Fair enough. So therefore, I can say P is equal to 10 to the power 5 is 1 lakh. Correct? It's 1 lakh minus 10 into 0.2 is 2. 2 into 10 to the power 3, that's 2000. So that's 2000. So 1 lakh minus 2000 is 98,000, which I can also write it as 0.98 into 10 to the power 5 pascals, right? So that is the new pressure. I think I will need it for something. Let's see. Yeah, it's JEE Advanced, of course. Is it the same principle in pens too? No. That's completely different. Oh, that's very good, Surya. I'm so glad. I'm so happy for it. So that now you don't have to worry about the clashes and all of that. Okay, Sai, I will be making a video on that soon. Don't worry. Now, if the air trapped expands, I can clearly think of only one thing: expansion of gases under constant temperature. That's isothermal expansion. And when isothermal expansion happens, pressure into volume is constant. So, in isothermal, because the temperature of this system does not change, isothermal expansion of the trapped air, I can clearly say initial pressure into initial volume will be final pressure into final volume. What is the initial volume? That's straight away I can say P naught. P naught is 10 to the power 5. 10 to the power 5. Volume, I can say it is area into this height. Area of cross section, let's just assume, right? Let's just assume it to be A. What's the harm? Okay, what's the harm? Yeah, let's just take it as A. Into this height, this will be 500 minus H. So this will be 500 minus H. Okay, this will be equal to final pressure, which I just figured it out to be 0.98 into 10 to the power 5 into final volume. Now this final volume, okay, let's just take it as area. Okay, I don't know. Oh, I know this height. I think I know, because this is 500. So naturally, this one over here will be 300 millimeters, right? Makes sense? If this total is 500, this is 200, this will be obviously 300. So this will be into 300. Area goes 10 to the power 5, 10 to the power 5 goes. So I'm just left with 500 minus H is equal to, what do we have? 300 into 0.98, I can write it as 98 into 3. Now at this point of time, some of you are wondering, sir has made some mistake in calculation, because 10 to the power 5 pressure is in pascals, Newton per meter square. Area doesn't matter, anyways it gets cancelled. 500 and H, well, 500 is in millimeters. So you might be wondering, how come I'm using SI units over here and how come I'm using millimeters over here? Let me tell you, it doesn't matter only for this particular calculation, because have you realized why it doesn't matter? Because it's the same thing on both sides. If this is in pascals, even this is in pascals. If this is in millimeters, then I have made sure that even this volume, area into height, that height is also in millimeters. So it will cancel out, so I don't really have to worry about the conversion. This is something which you can use in many parts of the calculation for different problems from different chapters. Yes, correcto. Now you just have to solve this. So what is H? Of course, H will be 500 minus 98 into 3. Correct? Barabar? So it will be 294, which will make it 206 millimeters. Just check this out. Let's make this height as 206 millimeters. That's it. I think I found the answer, but what has been asked? Find the fall in the height. Fall. What is the fall? This is the fall. This is the fall in the height. So hence the fall will be, initial height was 206, final height was 200. So this will be nothing but 6 millimeters. Done, done. Yep. Sprint is a revision series, problem solving series pushing yourselves from your basic to higher level for JEE Mains plus Advanced. That's what is sprint standing for. Where you run, sprint means you run. Okay, all this while you are learning around, say, walking, now you are running. So now is the time to run because the exams are around the corner. Okay, let's see the next question coming up on your screen. Very good, Kriti, very good, Arvinder, you guys got it. Okay, so what do we have here? Two bubbles A and B are kept in a closed chamber where the air is maintained at a pressure of 8. The radii of the bubbles are 2 and 4. Surface tension is 0.04. Find the moles which are there inside of each bubble. Let's try to visualize this first. Okay. See, you have a chamber. The chamber is maintained at a pressure of 8 newtons per meter square. Okay, this is your chamber. In that chamber, you have two bubbles. One bubble A of basically 2 centimeters and other bubble having radius 4 centimeters. This is bubble B. Obviously, there will be some gas trapped inside these bubbles. There will be some pressure inside. That means there is gas here as well as here, right? The question is, what is the ratio of the moles inside of it? This is very interesting. This was asked in 2009. Okay. So first of all, to find moles, what do we need? Let's try to realize that. P into V is equal to nRT. That's your ideal gas equation. Do you think the pressure of the gases will be same? Do you think the volumes will be same? Obviously not. Pressure will be different because the soap bubbles pressure depends on the radius, the size. Correct? So if the sizes are different, obviously the pressure inside is different. If pressure inside is different, I need to take care of that, but the temperatures are same. So hence, I can just say NA by NB is PA by PB into VA by VB. Okay, VA by VB. Now next thing that I will say is PA by PB and volume A by volume B. Well, think about it. The volumes are proportional to the cube of the radius. V is 4 by 3 pi r cube. So hence I can say this is RA by RB whole cube. Make sense, everyone? Great. Now the only issue is I know radius and radius of both the bubbles, but I do not know the pressures. I need to find the pressures, and for that I need the knowledge of surface tension, pressure difference, excess pressure in bubbles. So let's make use of that and try to see what do we get. We know that the excess pressure in a soap bubble is basically 4S by R. Hence, PA by PB will be, since it is inversely proportional to R. Oh, but these are not excess pressures, these are the actual pressures. Okay, let's try to figure it out. It will be P0 plus 4S by R1. That's the pressure of the gas in A. Remember, these pressures are actual pressures, not excess pressures. So PA is P0 plus 4S by R, and this will be also P0 plus 4S by R. So let's try to see what do we get this as. So P0 is 8, 4 into S is 0.04, so 4 into 10 to the power minus 2 divided by R1 is 2 centimeter, which is 2 into 10 to the power minus 2 meters, divided by, again P0 is 8 plus 4 into S is 4 into 10 to the power minus 2 divided by 4 centimeters, so 4 into 10 to the power minus 2 again. Let's see what do we get this as. So 8 plus, and here also 8 plus, 10 to the power minus 2 gets cancelled. 4 by 2, 2, 2 4s are 8. 4 by 4, 1. 4 into 1, 4. 8 plus, correct? Okay, 8 plus 8, 16. So 16 by 12, which is also divided by 4. So that will be 4 by 3. So I've got PA by PB as 4 by 3. So it's just a matter of substitution. So put over here 4 by 3. Rest all things are simple. And this is RA by RB. RA by RB is 2 by 4. So just put 2 by 4 and that is whole cube. Okay, so this will become 4 by 3. This will become 2 cube, which is 8, and here you will have 4 cube. So this will become, one of the 4's will get cancelled. So 8 divided by 3 into 4 square. So this I can write it as 4 into 4. So this 4 gets cancelled. This will become 2. This will become 2. Okay, so this will become 1 by 6. So that is NA by NB. So NA by NB is 1 by 6. Is the question the same? Oh, we have to find NB by NA. So NB by NA will be 6 by 1. 6 by 1. No, Jairub, I don't know that. Yes, the bubble has 2 layers. That's why 4S by Artahira. Yeah, correct, Arvinder. Yeah. So guys, realize one more thing, that there was a chance of silly mistake over here. Many people make a silly mistake. They forget to add the outside pressure. If you just write 4S by R, that's wrong, because that's the excess pressure. Actually is excess plus the outside one. Okay, very interesting question. And this was asked in JEE Advanced. And remember, this year also you have these kind of numerical question. So these kind of questions can also come in JEE Mains. Who knows? Okay, answer is 6. Moving on to the next one. Okay, priority subject is the one which has the lowest cutoff for JEE Advanced Buoyancy, Saburao. So it depends from year to year. Usually it is maths, then it is physics, and then chemistry. But things can change depending on the difficulty of the paper. That's only for advanced. Mains does not have individual subject cutoffs. A soap bubble is blown slowly at the end of a tube by a pump supplying air at a constant rate. Which of the following graphs represent the correct variation of the excess pressure in the bubble with time? This is easy. Let's try and do this. If you supply air inside a bubble, realize that the excess pressure, which is 4S by R, the excess pressure is going to increase because you are supplying more and more air. That means you are increasing the pressure inside. Hence, the radius of that bubble will decrease. So as pressure increases, radius decreases. So is it there? Okay, obviously what's going to happen? The bubble is blown slowly at the end of the tube by a pump. Yep, it has to be inverse graph. It has to be an inverse graph. So it should be option B. Check this out. Check this out. Yep, interesting. Very good, important. So what is happening is, as you are pumping in more and more air, you will see that the radius will keep on increasing and the pressure will keep on decreasing. Yep, you can see that. So if pressure increases, radius decreases. If radius increases, pressure decreases. So as the size grows bigger and bigger, you are going to see that the radius will keep on growing and you will see the pressure will keep on falling. Inverse graph. That's option B. Moving on to the next one. Hi Chikala, hi Molesh. Nice to see you after a long time. Wow, this is such a nice question. 2014 JEE Advanced. On heating water, bubbles begin to form at the bottom of the vessel and they detach and rise. Take the bubbles to be spheres of radius r and making circular contact of radius r with the bottom of the vessel. R is less than r. Find the surface tension of water. If it is T, then find the value of r for which the bubbles just detach. Beautiful question, okay? Let's try and do this. Understand this first. Bubbles begin to form at the bottom of a vessel and detach and rise. There is a critical radius for which they just detach from the surface. Remember, the circular contact is made of radius r, but the bubble's radius is capital R. The bubble's spherical radius is capital R. What does that mean? So imagine this. If you have a bubble, something like this, imagine a small cut in it. So it would look something like this, maybe. Just imagine something like this. This is your bubble. Okay, this is your bubble, something like this. And imagine a cut. And once you visualize a cut, it's just like taking a potato or a tomato and just slicing it. You get a circular area, right? So try and visualize a circular area over here. Try and visualize a circular area. This is the center of your bubble, and this will be your radius of the bubble. but the radius of the circular contact, that is small r. See if you are able to visualize this. Okay, very interesting thing. And let's just start seeing why will it detach, what are the forces on it. Okay, now just imagine this is your base, on which that yellow part is just attached. Just visualize that. Okay, this is the base on which the circular yellow part has been attached. Now it is going to detach itself as the bubble's buoyancy will push it up. The bubble's buoyancy is going to push it up. Correct? Okay. What is the force which is preventing it from detaching? Bubble's buoyancy pushes it up because of the outside liquid. There is one force, and that's surface tension. That's the reason why surface tension is mentioned. Look at the periphery. They will all get pulled because it is stuck to that surface. Surface tension forces like a capillary tube. Remember, a capillary surface tension forces acts everywhere. Hence, no, it's not normal, it's the surface tension force. When it detaches, the normal will become zero. In fact, Arvinder, when two surfaces lose contact, normal becomes zero. So just before losing contact, what is there is that you have the surface tension forces. It will act like this. It will act everywhere. Okay, I don't want to mess up the diagram, but yes, I just want you to realize it is there everywhere. Okay, throughout the thing. It's like this, inwards. Imagine a vector here, 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 here. Everywhere it is there. Everybody able to understand this? Like a frustum of a cone, but the arrows are pointing here. The buoyant force is obviously upwards. The buoyant force is obviously upwards. Just to redraw the diagram so that we can do the geometrical part very nicely. Okay, this is your R, and this is your height, and this is your smaller radius. And then we also saw that the surface tension continues over here. Surface tension force is here. Okay, this is the force due to surface tension. And for simplification, let's assume this angle to be theta. Then this is 90 minus theta, and even this angle is theta, of course. Okay, this is theta. And you can now think about two components of the surface tension force. One component downwards and the other component this way. Can you see two components? One is the surface tension's cos theta component, and the other one is surface tension's sin theta component. It will be there everywhere. Now, throughout the circle, just imagine two components. One component like this, one component down. One component like this, one component down. Think and tell me which component will get cancelled. Think clearly, use your brains and give me the answer. Even if you're wrong, it's okay. There are two components at each and every point. Remember, the surface tension will act as a continuation of that curved surface. Surface tension always acts along the surface. So the surface ends there. So that's why the surface tension force continues over there. Okay, so it's a continuation of that. Okay, so think about it, that which component will cancel, which component will be there. If you look at the cos components, cos is there everywhere in the horizontal plane. So all the cos components will cancel. Do you see that, my warriors? You see cos component from here, here, here. It's like this. I'll just show it to you. One cos component will be here, from here, from here, from here, from here, from here. These are basically all your cos components which are in the same plane. So the cos components will cancel. What will add is the sin theta components which are down. The sin theta components, all the sin theta components are like this. All the sin theta components are like this. Look at that. All the sin theta components are down, 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 down. So sin components will add. Keep this in mind. So the net force down, which is preventing it from rising up against the buoyant force, is the sin component of the surface tension force. Everybody gets this? So can I say that the buoyant force which is acting upwards is being balanced by the force of surface tension's sine theta component. That's the final outcome that we got till here. To get this part, we have to do all this business. If you realize, not much of equations, it's just visualization, understanding, and having the patience to first formulate and lay the groundwork before writing the equations. You cannot straight away say, sir, which formula is applicable? No formula is applicable. First understand the problem. That's why it's a JEE Advanced type of question. So let's try this out. Everybody ready? Everybody fine till here? Are you guys alive? Dead? Let me know in the chat box. Okay, let's go ahead. Cool. So what's next? Buoyant force. What's the value of the buoyant force? Density of liquid, volume into G, right? Okay, V rho G. Volume is 4/3 pi r cube as a volume, complete volume. Ignore that small thing out here. Yep. So before detaching, it will have normal. Yes, bacha. But remember, the critical radius is what you want to find just before. So just before. So that's when normal has just gone almost. Okay. In fact, you can think the normal force is because of, see, normal, what is it? Normal is a contact force. In fact, surface tension is a part of the normal force. You can think of it that way. Or part of those molecular forces. Think of it that way. 4/3 pi r cube. Okay, 4/3 pi r cube into density into G. This will be equal to, all right, on the other side, what do we have? Surface tension, it's S into L. Length on which it is acting, the yellow part. So it will be surface tension into the length of this. What is the length of this circle? It is 2 pi small r. But also take the sine theta component. Do not forget that. Also take the sine theta component. Now it's just a matter of cancelling few things and solving it. So 4 and 2 gets cancelled, pi and pi also gets cancelled. So here I have 2 and I have r cube and I have rho and g and I have 3 over here. Here I have t, 2 and pi have cancelled, r and sine theta. Now if you notice this diagram, sine theta is opposite by hypotenuse. Technically speaking, the sine theta is opposite by hypotenuse. So might as well write that sine theta in that particular fashion. Yeah, so I can just write this as r by capital R. All right, what did I want? Value of small r. So except for r, shift everything else on the other side. So it will become 2, r cube into r will become r raised to 4 into rho into g divided by 3 will come below and t is obviously below. This will be equal to r square. So r will be equal to root of this. So root of r raised to 4 is r square, and you will have root of, and you will have 2 and rho and g, and here you will have 3t. I think that should be the answer. Do I have such an option? Yes, I think so. Option C. R square 2 rho g by 3t. 2 rho g by 3t, and r square is outside. Correct. What a brilliant question. Let's move on to the next one. Yes, please feel free to watch this again and again. Best books for mains preparation, Tatva. Also your PYQs by Arihant and H.C. Verma. Best books, nothing more. Okay, last few questions coming up on your screen, and here it is. This is a what do you say, capillary, but not of the same width. The width is varying. This was asked in JEE 2014. The shape is like a cone. The size keeps on changing. The cross sections are different. When dipped in the water vertically, the water rises till certain height where the radius of the cross section is b. So till wherever it rises, the cross section's radius is b. Surface tension is given, density is given, angle of contact is given. What will be the height rise? Okay. Now, do you remember the derivation for capillary rise? And if you have been attending my classes, you will also remember that I have been telling it's very important. If you want to crack JEE Advanced, you should know the derivations. JEE will not ask you derivations, but will check if you know the derivations or not. Here you need to know the derivation of height rise of a liquid in a capillary tube. If you remember, one of the ways to derive that is by equating or balancing the forces. The surface tension pulls the liquid from all the sides, so the meniscus starts rising up, but as it rises up, the weight of the liquid in the capillary increases. So the surface tension pulls up the liquid until it balances the weight, and the moment equilibrium is achieved, that's it, the liquid stops rising further. Same thing has to be used, but this small diagram is of no use to us. Let's draw a slightly bigger diagram. So let's think about it. This is like a cone because the size is increasing. So let's just say that this is one side. This is one. Okay, I've drawn it highly exaggerated, and just imagine this to be the angle bisector or something like that. Okay, let's say the cone angle. Is the cone angle given? With an apex angle, it had to be given, guys. I think that is missing. Let's just assume it as, if theta is given, let's just assume it as alpha. Okay, alpha is the cone angle. So if alpha is the cone angle, okay, this whole angle, if it is alpha, this angle will be alpha by 2. Okay, now water is going to fill up till certain height. So let's just say that the water has filled up till here. So this would be the angle of contact. Okay, surface tension acts along the surface. So surface tension will pull in this particular fashion. This is the force due to surface tension. Cool. Next thing, the radius at that particular section, because it's a conical section, radius at this part, this part, this part, the radius keeps on changing. At that particular cross section is B. That means this is B. Fair enough. And if this is the curved surface, it will also have a center of curvature. This will be the radius of curvature. So what is this? This is your radius of curvature. Very, very important. All these diagrams are important. Without these diagrams, you cannot do this. Okay. Now, think what is preventing the water from falling down? Because if the water has risen up till here, obviously, it's nothing but because of the force due to surface tension. That force is being balanced by the weight of the liquid inside of that tube, the weight of that liquid inside that tube. So all you need to do is figure out what is the component of the force in the vertical direction, because surface tension again has two components, one horizontal, one vertical. Horizontal will anyways cancel everywhere because this force will be there throughout the circle. All the horizontal components, just like before, will cancel. It's only the vertical components which will add up to give the net resultant force. For that, I need to know what angle it makes with the vertical. So let's try to figure that out as well. Notice that this is the vertical and I need to know the total angle, and I think I know how to do this. Observe this angle. Do you know what this angle is? If this is alpha, this is alpha by 2 from vertical to this slanting line. This is also alpha by 2. If this is theta, the opposite angle, observe the opposite angle. If this is theta, the opposite angle, this one, is also theta. So what's the total angle which the force makes with the vertical? What is this total angle, guys? This total angle is obviously theta plus alpha by 2. Correct? It's theta plus alpha by 2. So a lot of people made a mistake in 2014 by missing either alpha by 2 or theta, because they forgot that the total angle will also have this and this contribution. Notice again, the vertical is this line. The white line is not straight, it is tilted. So because of that, that extra alpha by 2 has come, and the theta has come because of the angle of contact. That's all. So a lot of people either miss this or that. Now the equation that I will say is the force of surface tensions sine theta plus alpha by 2 component. Okay, oh sorry, why am I saying sine? It should be cos, my bad, because it is adjacent, right? So force cos component, cos of what is it, theta plus alpha by 2, this should be balanced by the weight. So what is the force of surface tension? The force of surface tension will be surface tension itself into the length, Now the length, we'll put it later on, hold on. So cos of theta plus alpha by 2, and what do you put the weight as? Just check this out. What will be the weight? Density is given. Acha, I can just put it as rho gh, or do I write it in terms of force? What else is given? Is height h also given? Yep. And the angle is small. Yep. I can write it as pi b square into rho gh. Just check this out, everyone. Fine till here? Yes. Just check this out. Cool. Very good. Now, what else is there? What else is there? L. What is L? L will be nothing but, just check this out, the length of that arc, of that entire region, will be 2 pi r. 2 pi r. R is b. So this will be 2 pi b. Just check this out. 2 pi b will be the length across which the surface tension is acting, and this will be cos of theta plus alpha by 2. This will be equal to pi b square, which is the area, into the height, okay, will give the volume, into rho g. So that will give you the total weight. So pi b will cancel. You just want the height, right? So I think one of the two will remain, s will remain, cos will also remain, theta plus alpha by 2, and the whole thing divided by this b has come down, and rho has also come down, and g also has come down. That's it. That's your height. Just check this out. Yes, it is 2s b rho g cos theta plus alpha by 2. This part I hope you guys understood. This is nothing but density into volume will give you, okay, into volume will give you mass into g. So volume is the volume of a cylinder, approximately. This is approximate. You can do that. It's fine. Cool. That's how this has been done. Brilliant question. Let's move on. So now you know how to solve questions where the surfaces of the capillary are not straight but inclined to the vertical. You know that now. In an experiment to verify Stokes' law, small ball has been dropped through gravity through certain height. Now before it enters the tank, okay, it drops by certain height. Now it so happens that the terminal velocity of the ball in the water is same as the velocity just before entering the water. What is the height proportional to? Interesting. Let's try and do this. Not that difficult. I feel 2019 question. So you have this ball, you drop it. So eventually it will get some velocity. Let's mark this velocity as v. But as per the question, just before entering the water surface, this is the velocity. As soon as it enters the liquid, one would expect because of viscosity, the velocity will decrease and so on and so forth. But luckily, that velocity is the terminal velocity. So it continues moving down. That means that the velocity which the ball acquires by dropping by certain height, happens to be the terminal velocity. So my equation will look like this. Velocity after dropping is velocity of the terminal, and velocity after dropping is root of 2gh. Terminal velocity is 2 by 9. You have g, you have r square, you have sigma minus rho, and here you have eta. Square both sides. I mean, like, look at this. All the things are constant anyways. So root of h is proportional to r square. So h is proportional to r raised to 4. As that's what has been asked. What is it proportional to? Option B is correct. Option B. Yep. Very good. Forces must also be doubled of the other side. Arvind, you mean for the previous question, for weight, for surface tension? What are you talking, Arvind? Sundaram Gunjan, this is English channel, bachalo. We have a Vedantu Hindi channel also. Please join it, because you know, if you are comfortable with Hindi, you should consider joining the Hindi channel. But if you are in English medium and if you have you know, a longer outlook and you feel that yes, in the future I would be continuously learning in English, talking in English and all of that, then you should consider you know, learning in English at a very early age too. Okay, so let's move on to the next question. What do we have over here? A ball, solid ball, spherical, of volume V is made of some material. It's falling through a liquid of some other density which has I think density less than 1. I'm guessing it is in grams per cc. Okay, assuming that the liquid applies some viscous force on the ball that is proportional to the square of the speed. Usually drag force is 6 pi eta rv. Here the constant ignore, but it is proportional to square of the velocity. Then what do you think is the terminal velocity of the ball? Let's try to understand. Again, 2010 question based on derivation. How many of you remember the derivation of terminal velocity? If you know the derivation, you can solve this, else you will be stuck. You will waste time, you might get it, but you will waste time, that's all. In the derivation, if you remember, if this ball is there or this drop is there, there are multiple forces that you show. One of the forces that you show is obviously the weight of the ball. Another force that you show is the buoyant force, and the last force that you show is the drag force. Remember, the ball is coming or falling down, okay? It has some velocity like this. Now, okay, now when terminal velocity has been achieved, that means this velocity is constant. This velocity is constant. Can you guess what will be the acceleration? Can you guess what is the acceleration? No problem, Arvinder. Now you can see it. I mean, over here, whatever you learn will be almost like 99% the derivation of terminal velocity. If the velocity is constant, acceleration is 0, because velocity is not changing, right? So acceleration is 0. If acceleration is 0, obviously net force is 0. If net force is 0, weight balances these two. So weight will be buoyant force plus drag force. Weight, that's volume, is it given? Yes. Weight will be mass into gravity, so m into g. Buoyant force will be density of the liquid. Density of the liquid, rho 2. Volume submerged into g. Plus drag force. Now some of you will be like, should I put minus? What do you guys think? Should I put minus sign? Obviously not. This minus sign signifies that the drag force is always opposite the velocity. But you have already shown it opposite the velocity, so why bother put the minus sign? It's like when you write spring force as kx, you know the direction is opposite to x. You don't again put the force as minus at kx. That would be stupidity. Okay, so just put it as k v square. M, mass is density into volume. Density of the material is rho 1, volume is v. So into g is equal to rho 2 vg plus kv square. So I want velocity, so kv square will be, vg is common, so you will have rho 1 minus rho 2 and put that k below. So v square will be, this is volume, don't get confused, or else you will end up cancelling it. This is velocity, guys. This is velocity, don't get confused. So vg, rho 1 minus rho 2, the whole thing divided by k. So obviously the velocity will be root of that entire thing, which is vg, rho 1 minus rho 2, the whole thing divided by k. And I think I have such an option there, which is option B. Okay, I think this was either a mains difficult question or advanced normal question. Okay, got it? So brilliant question, guys. And I think, yes, so those are the questions that I had for today. But if you're loving these kind of sessions and you want to practice more questions like this, you want to sharpen your skills, you want to practice variety apart from the ones which are taught in your school or your institution, or you have not yet started learning via some college or via some institute, then now is the best time to ace up, build up your preparation levels, because at Vedantu I am offering you the best course for cracking JEE or even for NEET. You have all kinds of crash courses, pro subscriptions right now available. Let's say for example, if you're a JEE 2022 or a NEET 22 student, then you have the crash course with live classes and recordings with mock tests, which are including part and full syllabus with report cards, with all the analysis, with all India rank predictions, and also you can compare your results with those students with whom you are actually going to sit and compete. Not just that, you will get all the PDFs, the recordings, and you will also get the session notes, and also you will get the facility of doubt solving. So this is how our platform looks like on the paid version. It's okay, let me just probably open it up. Yes, let me just pull up the screen right over here. There you go. So if you are on the Vedantu's paid platform, it looks something like this. You can see your schedule, you can see your past sessions. So depending on which course you are enrolled and which courses you're not, all those sessions will pull up over here. You can see, you can attempt all the tests, you can view the reports of how your performance was in all the tests, your accuracy reports, subject wise, difficulty wise, topic wise. You get lots of study materials, sample papers, notes in your content. You also get your assignments right over here. You can continue your assignments, move on. You can see how many questions were correct or wrong. Not just that, if you go to your courses, my courses, you can see which courses you have been enrolled into. You can start seeing the timings. You can obviously also watch the recordings of these classes. So this is how the paid platform looks like, and there are obviously, like I told you, you have the facility of also getting a two-teacher model where the second teacher is constantly solving all your doubts. So it's all in your hands. It's up to you how you want to utilize this. What was the percentage in 11th standard? It doesn't matter, Arvinder. It was normal, like 85, 86. I mean, for me during that time, for us, and even for most of my students, what matters is getting a JEE, rank and clearing JEE. So, board's percentile used to matter till some time because they used to have eligibility and all of that. But otherwise, it really doesn't matter. So you should also not worry about it. Focus on JEE. Automatically, boards will get taken care of. And in Vedantu Pro courses, we also have your preparation done for even boards examination. Now, if you're in the crash course, the usual price was 20,000, but offer price goes to 10,000. But using my coupon code, because you're watching my lecture over here, it comes down to just 8,000 bucks using my coupon code SHCC. So if you're wondering where to join and how to join the Vedantu's Pro subscription, it's all over here in the description box below. Just go down in this video. You will see JEE crash course. You also have the JEE 2-year course. That's for the 11th to 12th moving students. You get the entire 11th standard recordings as well. So this is a JEE crash course. If you're targeting NEET, select this. Same coupon code, same price. All the benefits are available for you. You can see everything has been mentioned right over here. It says unlimited doubts, everything, boosting your rank. You can choose which batch you want to start, and end dates are also mentioned right over here. So just say buy now. There it goes. You have saved 1,000 and it comes down to 8,000 bucks. Obviously, you have multiple options. You can choose whichever payment mode you want to enter into our platform. It's wonderful when you learn via the Wave platform, which is our Vedantu's patented platform, plus YouTube. That combination is deadly because nobody can stop this unstoppable force which you will be entering into. So I would love to have you there. I hope you guys had a great time. Okay, hello Games Master. I think you are a little bit late. Hi Deshant. So I hope you too will make the best use of the PDFs that I'm going to provide you. In the description box there is a link for joining Telegram group. Join the Telegram group and you will be getting the PDFs. All right. Was I studious? No, I was very average. I was mastikhor. I was chilled out. Okay, not very cool, but not very studious. I was like, yeah, I will enjoy my life. I will study also, I will play also, I will do masti also, I will do all kinds of mischief, everything. Thank you, Kushgara. Yo, take care, have a great time, and I will be seeing you next time. Any doubts that you have, please let me know in the comment section. And yes, you know where to contact me. That's my Instagram profile, Shreyas_Vedantu. Take care, have a great time, study well, work hard, let's crack it together. This was Captain Shreyas signing off. Hasta la vista.